Now we're on to note card 150. And if you didn't finish up note card 149, go ahead and pause me and finish that one up. All right, so this is just some more examples, and it wants me to use this diagram, and I can see that I have these perpendicular distances, and also it tells me that ray BD right here bisects the angle because it's not marked like that. It's not marked, so I can't just assume. So, but it tells me right here. And then it tells me DC, this little length is 6.9, and wants me to find DA. Well, it would be 6.9. Then a different scenario, it says find the measure of angle ABC, guys. That's the big angle, ABC, when AD is 3.2 and CD is 3.2. So what they're saying is those are equidistant. So once I know that they're equidistant, I can then infer that this is an angle bisector. And so it tells me that angle DBC, I follow that out, DBC right here is 39 degrees. Well, if this one right here is 39 degrees, so is this one because it's an angle bisector. So 39 times 2 is 78 degrees. So the big angle ABC is 78 degrees. Pause me and finish up note card 150. Oh, and yes, you need these diagrams. All right, here's another one, note card 151. So it's the same picture, but new information. Yes, BD is a bisector, it states that. Then it tells me that AD's length, AD is a segment, is 3Z plus 7, and CD is a segment, its length is 2Z plus 11. Well, what do we know? We know that they are equidistant, so we set them equal right here. Solve for Z, and it's asking for CD, not for Z, but we had to find Z first. So once I have Z equals 4, I plug the 4 in right here to this Z spot because I need CD. 2 times 4 plus 11 is 19. Pause me and finish up note card 151. Now we're moving on to the perpendicular bisector definition, note card 152. A perpendicular bisector is a special kind of segment, ray, or line that does two things. It intersects a given segment at a 90-degree angle like this, and it passes through that segment's midpoint. So this is a great example. We've got a segment AB. Its midpoint is D. How do I know that? It's marked. I see these tick marks. I see these tick marks, okay? And this purpley box tells me it's perpendicular. So CD is the perpendicular bisector. And I wrote all this up over here, and it may seem overwhelming, but you need to read it. There's a square purple box indicating right angle, which is perpendicular at angle CDB. There are also two single black tick marks that mean AD is congruent to DB, okay? This means that D is the midpoint. Therefore, this segment CD is called the perpendicular bisector of segment AB. It's perpendicular and it bisects. Finish note card 152. All right, note card 153, of course, there's some special relationships, and this is the perpendicular bisector theorem. If a point actually lies on the bisector, so right here, this is the bisector, the point C lies on the bisector. If that happens, it's equidistant to the endpoints. Remember, with angle bisector, right here, this point was equidistant to the side, okay, to the side of the angle. On this one, this point is equidistant to the endpoints. That's the biggest difference. And I went through how we know it's perpendicular bisector and all of that. And then right here, since line CP is the perpendicular bisector of segment AB, we can conclude that C is equidistant to the endpoints A and B, meaning that the length of CA is equal to the length of CB. Finish note card 153. This is just an image and it's probably overwhelming, but I think some of you might benefit from it. This is a perpendicular bisector and I've drawn several different points, okay? So AH is congruent to HB because it's on the perpendicular bisector, so it's equidistant to the endpoints here. AG in orange is congruent to GB in orange. In green, AF is congruent to FB. And in red, AE is congruent to EB. That is the perpendicular bisector theorem. That's what it's talking about. Here's another image to give you some other ideas. AD is the same as DB. AE is the same as EB. AF is the same as FB. And then over here's that example I took away from earlier. We can conclude that 5x equals 3x plus 8, solve for x, and then plug back in and get QR.